Hello students, last class we discussed about the estimation of wastewater or sewage flow, right? So it is two things, it comprises of two things. One is wet weather flow and another one is the dry weather flow. Okay, so now in today's class we are going to see the fluctuations in the sewage flow, right? Fluctuations in the sewage flow, because here the sewage flow may not be same for 24 hours in a day, right? So in a day it won't be same, right? So when sewage will generate, whenever you are utilizing the water supply to the people, right? So then only wastewater will generate, but the usage of water will be different from one time to the another time in a day, right? So morning people use more and evening also will be more. During midnights and mid afternoon the usage will be very less. Then the sewage flow will be also very less. Okay, now I can see here the first point is telling that, right, the sewers may not flow completely full. It never flows in the sewers. Average sewer never flows in the sewer. That means if you are taking any sewer, right, this is a circular sewer, right, so this is designed to carry the sewage, right. So if you are seeing this is the half of the flow, right, it won't reach to completely, but always it should be less than, or it will be look like this, even it will be look like very small flow, right. You can see in this real time picture of this sewer, you can see this is the very big diameter that the water is flowing very low, right. So like sometimes some other times it will come to this point, it will come to this point based on the time, right. So the first one is saying that practically the average sewer never flows in the sewer. It continuously varies from hour to hour of the day and season to season, right. We will see the first thing, hour to hour. I already told that in a day we will have a different times for usage of water, and accordingly the wastewater will generate. Normally in the morning times and the evening times will get much flow compared with the other times of a day. Then coming to the season to season, right. So if you are taking any rainy season, right, the flow will be more, and if you are taking any summer season, the flow will be very less. That's why the flow will be depends on season to season and time of the, that is hour of a day. Okay, so next you can see next point, the design of sewers should be done for the maximum possible flow, right. So you have to predict what will be the maximum, that particular sewer has to carry maximum flow. Okay, for that we need to design, then only it will be safe. And also here the sewer pipelines will be designed as a open channels. It is designed as a open channel, right. It will be designed as a open channel. We already know there are closed two things, that is closed flow, pipe flow, and is open channel flow, right. So it is if it is a closed pipe now, so normally this is pressurized, right, completely the water will be throughout the pipe. This is called pressure pipeline. If you are taking open channel, right, flow, it will be, the water surface will be exposed to the atmosphere, the pressure will be atmospheric pressure there, right. So now if you are taking any flow, what is called sewer pipeline, right, so we have to maximum water occurs up to this level, remaining will be left as a free, right. So we have to leave it as, okay. So we will see what is the reason, okay, why it is designed like that, okay. But now we need to know that the design of sewer should be done for the maximum possible flow, right. Even you are including money, rainwater, everything, right. All calculations should be considered for designing what is called, for designing the sewer. Okay, what is the meaning of design of sewer means you have to know what is the diameter, right, size, right. You have to know the diameter or size. It is a circular thing, we are going for diameter. If it is any other shape, you have to give its dimensions, right. This diameter dimensions will be depends completely on the discharge. We already know that the discharge, based on discharge only you are going to get the dimensions, right? So next, see here, this is the graph given, right? So with the different timings, you can see here, this is the 8 a.m., right? Morning 8 o'clock and evening 6 o'clock, that is 6 p.m., right? So here we have two graphs here, right? The first thing is, this is called water demand curve. Even in water supply engineering also we saw there were fluctuations in the water demand during hours of a day, during different days of a week, different weeks of a month, different months of a year, right? Season to season, like that. Here also water sewage flow also will be different, right? You can see here, based on this water demand, the sewage flow will be airy, right? During morning 8 o'clock, the flow is very high. Before morning 8, this is during midnight, no, it is very less. Again, evening it will be more, right? By night time it will get reduced. Okay, so you can see here also, this is another thing. Okay, it will represent same only, right? Okay, so this is to show what is the average value. Okay, so here the thick line, okay, this thick line is water demand and the dotted line represents the wastewater flow, which were already showed in last picture, right? Last graph, right? So here it is average value, here it is dotted line is the average value of wastewater, this thick line is average value of water demand, right? Now the peak will differ if the sewage has to travel long distance, right? Here what is going to tell, if I have a one sewer, case number 1, right? This is the case number 1. I have very short length of sewer, right? So I need to collect sewers from individual houses. This is house number 1, on side this is, here also we are having on 2, like that. It is having so many joined, okay, to the main sewer, but it is having very less length, right? This is a small length of sewer, right? So here, if small length of sewer, if you are calculating the discharge this point, okay, so to arrival of all the sewage waste from different sources, it will take very less time. Okay, so here the fluctuations will be very less. Whenever we are giving, water will come at a time. Okay, we are taking another second case, that is where the length of sewer is more, very big sewer, right? Like a city, like a Hyderabad, okay, that kind of cities. If you are seeing, no, the sewer pipelines will be very small, since the city is very big, right? So during this, the water or sewage starting from this point, okay, it has to travel much distance to arrive at a particular point where I am calculating my discharge, right? It will take so much time. That's why fluctuations will be very high. Okay, so all water to get what is called, to arrive all waters at particular distance, it will take so much distance. Here it is telling the first thing, the peak will differ if the sewage has to travel long distance. If it is in the second case, we are telling that the sewage is traveling long distance. Okay, so the peak means in the graph we already saw, okay, time versus discharge, right? Morning very less, early morning 6 o'clock very more, then evening 6 o'clock very high, right? So like this, these peaks are there, no? These peaks will depends upon the distance, how much distance the water is flowing in a sewer, right? So this is the because why this is happening, why the peaks is different means, I already told, the water travel from this point to this point will take much time, right? So that's why it will be differ. This is because the time required in collecting, right, sufficient quantity of sewage required to fill the sewer and time required in traveling, right? So if you want to fill the sewer completely, right, to fill completely, na, every flow has to come from this point to every point, and it has to reach here. Okay, it will take some time, right? Even to travel from this to this point to this point, it is also taking much traveling, right? So quantity has to become and has to time as required in traveling. Next, as sewage flow in sewer lines, more and more sewage is mixed in it due to continuous increase in the area being served by the sewer line, right? If starting from this point, sewer pipeline is lining like this, right? So many other pipes also will add it to this, right? Continuously it will collect from all points, right? So once it is getting all sewer, what is called, all quantities coming into the main sewer, automatically, right, sewage flow will be increased due to it is serving more area compared with the case number 1. It is serving very less area, right? This leads to reduction in the fluctuations in the sewage flow and lag period goes on increasing. Okay, if these kind of long length pipes are used, what is telling, it is a reduction in the fluctuations. That means if you are having very less length, you will get more peak, right? If you are having greater length of things, you won't get peaks like this. That is the difference between, this is the shortest length of pipe, this is longest length of pipe. Here fluctuations are very less, that means the peaks are very less. But in case of case 1, okay, we can tell that this is case 1, this is case 2. Case 1 will have very high peaks, and case 2, because of long distance, okay, it doesn't have any high peaks. Okay, so next point, the magnitude of variation in sewage quantity varies from place to place and it very difficult to predict, right? So it never depends on how it will depends on place to place, means we have so many atmospheric conditions, right? Weather conditions, right? So based on weather conditions, some area will give more water, some area will give less water. Then another thing is based on soil permeability, right? If you are having soil, it is more permeable, so easily water will be absorbed. If it is a laggy layer, you will get more thing, right? That place to place, right? Even it will be depends on amount of quantity of water supplied as a drinking water. If you are supplying more water, automatically more wastewater will be generated, right? So if you are supplying less water, less quantity will be generated. Next, for small township, this variation will be more pronounced due to lower length and travel time before sewage reaches to main sewer, and for large cities this variation will be very less. Already I told that for small cities, there the length of pipe will be very less, so peaks will be very high. In the second case, if it is a big city, the length of pipe will be very more, right? So you won't get much fluctuations, right? That's what he is telling here. Okay. Next, now to estimate estimating the design discharge. Okay, if you want to calculate design discharge, okay, so you have to use these following relations, right? Now the maximum daily flow, if you want to know what is the maximum amount of daily flow which is flowing in a particular sewer pipe, this should be 2 times the annual average of daily flow, right? 2 times of, so it is equals to 2 times of, right? 2 times of average daily flow. 2 times of average daily flow. Okay, so that is given for the maximum daily flow. Next, coming to the next thing, maximum hourly flow. Maximum hourly flow will be 1.5 times of daily flow. Okay, so maximum hourly flow. Okay, this is 1.5 times of daily average flow, right? Sorry, maximum flow. Okay, maximum. This here we are using the maximum daily flow. There we are using annual average daily flow. Average daily flow. Okay. And also this is equals to 3 times the annual average daily flow. Okay. This value is 2 times of this value. Okay. That's what he is telling. This is equals to 3 times of average daily flow. 2 times of average daily flow. Okay. Now, as tributary area is increases, right, the peak hourly flow will be decreases, right? As the tributary area. Tributary area means catchment area. Okay. If it is having a many muds area, right? If there is any very wide area and big area, no? So if it is more, what is telling? The peak hourly will be decreased, right? That's already saw in the last diagram. Okay. For here we are having different values, right? Values of factors based on the population here. Now, for taking here for smaller population, that is less than what? How much this? 50,000. If it is a city having less than 50,000 people, the peak factor can be 2.5. The peak factor can be 2.5, and the population served increases value decreases. If population is increasing, no, the peak value will be very less. For 50,000 it is 2.5. If for large cities it can be considered as a 1.5. Okay, 1.5 to 2. Okay, what is telling? In the first case, if the population is less than 50,000, okay, the factor will be what is how much? 2.5. In the second case, what is telling? If P is greater than 50,000, right, the factor is taken as 2 to 1.5. 2 to 1.5. Okay, therefore, for outfall sewers, the peak flow can be considered as 1.5 times the annual average daily flow, right? So here in what he took here, last time here took 2 times, here we taken as the 2 times, but for outfall sewer we have to take here as a 1.5, we have to reduce, no? That's what he is telling. Then even for design of treatment facility, the peak factor is considered as 1.5 times of annual average of daily flow. Here we took as a 2. Instead of 2, you have to take 1.5. That's what he is telling. Then peak flows for lateral sewers are much greater than that of the large trunk sewers because more flow time for trunk sewers compared to the laterals, right? So in a sewer system, this is the main sewer line, right? We have so many other lateral pipes where small pipes will come and join with these thing, no? So this is the one sewer lateral one, this is one, this is the lateral, this is main sewer, this is main sewer. Okay, like this so many laterals will come and join. Here what is telling, for lateral sewers, right, the freaks will be much higher. Why? Because immediately water will come. If immediately water will come, if you are taking a graph, peak will be more high. But for main lateral, no, right, this is the trunk sewer or main sewer. Okay, for this thing it will take so much time from the water will take from this point to this point. That's why if you are taking graph, the peaks will be like this. It should not be like very high things, right? So that's what is telling in this point. Then sewers are designed for carrying the maximum hourly flow of 3/4 full. How much? 3/4 full, not completely. If I am taking a complete sewer pipeline is, okay, 3/4 means this much, approximately less than or equal to, this was not fully, that much amount only you have to carry hourly, right? So that is the design. Why we are taking the design now, we will see in the further sections, right? Now minimum flow, what is the minimum flow should be required in the sewer lines, why it is required, right? So now he is telling that the minimum flow passing through sewers is also important to develop. The thing is called, very important thing, self-cleaning velocity. What is that? Self-cleansing velocity. Okay, so whenever you are taking a pipe, right, whenever you are taking a sewer pipeline, this is we are seeing from side view, right? Suppose here there is a sewer, what is called sewage is flowing along with the sewer. This is the sewage, okay, sewer line, water is flowing. Okay, so in wastewater we already know that there are so many what is called things will be there, even food material, fecal matter, then sand particles, any other garbage, something they will put into sewage. No? So if this water or sewage is moving very less velocity, slowly it is moving. Now, what is going to happen if flow is very less? There will be a phenomena called, we already see in the water treatment, that is called sedimentation. What kind of thing, what is this? This is the settlement of the particle, right, in a very low velocities. At low velocities, the particles, the solid materials which are flowing along with the sewage, they are going to settle in the bottom side of the sewer. If you are seeing in a cross-sectional view, right, if this is the sewage flow, at bottom all the dust particles, solid material will be get accumulated, and due to this the flow will be obstructed. Okay, the flow area is occupied by this unwanted solid material, right? So our flow will be interrupted, right? So it will leads to so many other problems, right? So now we have to make a minimum velocity or minimum flow, right? Then only no matter will be settled in the at the bottom of the sewer line. If we want to maintain no settlement or no silting, no sedimentation, the flow will be in a somewhat minimum velocity. Then only no solid material will be settled in the pipe, and with the speed of that velocity of that particular sewage, all material will get taken away along with the water. Okay, that's what is telling, right? The main minimum flow passing through sewers is also important to develop the self-cleaning velocity to avoid silting. This is called silting. The settlement of solid particles in the sewer pipeline called silting. Next, this flow will generate in the sewer during the late night hours. Okay, the effect of this, the flow is more pronounced on lateral sewers than the main sewers. Okay, main sewers compared to main sewer, this will be more having effect on the lateral things. Okay, next, slope at which sewers is to be laid is decided based on the permissible minimum velocity at particular minimum flow, right? So if your pipeline is like this, it is having very less slope. If you are laying like this is having much slope compared to the first case, right? So if you want to generate very less velocity, this flow is enough. If you want to maintain some good velocity, if slope is more, automatically water will move very fastly, right? So this is decided based on the permissible minimum velocity. How much minimum velocity, based on that we are going to see the slope, right? Next, sewers must be checked for minimum velocity as follows. Okay, by using these two things we are going to check what will be the minimum velocity in that particular sewer. Okay, here the minimum daily flow is equals to, right, it is 2/3. How much? 2/3 annual average of daily flow, right? Next, minimum hourly flow, it is half of minimum daily flow, half of minimum daily flow. Okay, so among this minimum 1/3, right? So 2 to here, how much it will become? 1/2 into 2/3, right? Annual average daily flow. Okay, 2 will get cancelled, will get how much? 1/3. This is the 1/3 annual average daily flow. This much flow has to be maintained in a sewer pipeline so that no silting will occur. Okay, now here sewers must be checked for minimum velocity at their minimum hourly flow. We have to check for their minimum hourly flow. Okay, the overall variation between maximum and minimum flows is more in the laterals and less in the main or trunk sewers. Okay, what is telling, right? The main. Okay, already we told that the maximum, what is the maximum here? Maximum flow is how much? It will be, okay, we already mentioned it should be 3/4 of design. How much? 3/4, and that means it will come up to this level. And next, now we are seeing the minimum flow. Minimum flow is how much? It is already we told that 2/3 times of right? Here we saw that 2 by 3 times of annual average daily. Okay, this 2 by 3 of average annual required. We need to take care there should not be any silting or sedimentation. Okay, and next he is telling that the overall variation, right? Okay, so to the maximum to minimum, this variation will be more pronounced in laterals. Why? Because it will take lateral will be very less distance and it will carry water within less time. But you are taking trunk sewer, very big pipeline, no? So it will take much time to travel from one point to another point. That's why the maximum minimum variations will be very less compared with the laterals. Okay. Now this ratio may be more than 6 for laterals, minimum to maximum. Right? What is telling? Minimum to maximum. If I am taking a ratio for laterals, it will be 6. Okay. And if I am taking this is for laterals, right? If I am taking a trunk sewer, okay. If I am taking a trunk sewer, this ratio will be less 2 to 3 times. Okay, you can see here. For laterals it is 6, for trunk sewer it is 2 to 3. Okay, so now I am concluding today's class, right? So in today's class, what we saw from starting, first point we saw what is the reasons for fluctuations in fluctuations of seaways, in sewers. Okay, so now we saw the one graph, right? On the graph, how it is showing the variation of the flow. Okay. Next, we saw what is the maximum velocity is required or maximum flow is required. Then we saw what are the minimum flow conditions required. Why it is required. Okay. So that is the things we studied in this class. Okay. So thank you.